Abbiamo dimenticato le madonne. Vedo bene, si viene qui. Andiamo a vedere la fabbrica. Perché che també poi la figlia del domenicano. Cái cảnh tôi ấy cái phim anh là nó phải mới đại gia có giờ về đã nó phải phải anh làm gì rồi đừng mà anh thấy cái đó thì tôi sẽ không tại từ từ cái trong
Okay, good morning, class. Okay, have you guys enrolled into my ULearn course page?
yeah.
Okay, because second one and second two, I have altogether 117 students. But here I see only 65. Okay, attendance, section 2. Any section 1 students? Okay, so this is the ULearn course page. Okay, as usual. Okay, I will put the WhatsApp link group and the M Teams here. Okay, so if you haven't joined, please enroll yourself into the ULearn. Okay. One BNKC 1013 differential equations, and join into these two. So under general info, you see the learning outcome synopsis. Okay, later we will go through the teaching plan. Okay, and one more thing, I want you to select a section. Okay, select a section in the ULearn. Okay, under the tab of group. Okay, select your section. Okay, and for week 1, okay, week 1, this is our first thing. Okay, I have because I have canceled the first slot. Okay, so I read this week. Okay, we should go through all this. Okay, but I think today we are able to go into describe the basic concept of differential equations. Classify the differential equations. Okay, maybe the other two we will look at the other two in next week. Okay, and for all of the slides you can get under lecture. Okay, under lecture. Okay, I will use my own slides and I put the OCW slides into ULearn as well. Okay, in the OCW slides, this is produced by mathematics lecturer by a number of mathematics lecturer. Okay, this one decided this. So you can download the OCW slides, okay, from this website. Okay, and there are quite a number of examples. Okay, you can look at the examples and the slide. Okay, but I will in the class I will use my own slides. Okay, I will use because my slides contains more exercise. Okay, but OCW slides, it contains more examples. Okay, so we can refer to the examples from the OCW slides. And during the class time, I will focus more on the practical. Okay, we will hands-on doing some exercises in the class. Okay, and tutorial, I have uploaded the tutorial question. Okay, and Okay, I will collect the feedback for every week. And those who attend the online class for this class, okay, and especially from section 1, okay, so you just submit the exercise into this link. Okay, then I will check the attendance. Okay, for those who attended, not attended online class, for those who watched the recorded video. Okay, for those who watched the recorded video. Okay. Now we look at the teaching plan. Okay. From the teaching plan. Okay, we start from the title first. Okay, the title is differential equation. Okay, differential equation, it means in this course, okay, you will look at many different equations that contains the derivatives. Okay, the derivatives that's mean y prime, y double prime. All these are derivatives. So when an equation contains this y prime, y double prime, it will be a differential equation. Okay, so throughout this course, you will learn different methods to solve different kinds of differential equations. Okay, these are the learning outcomes. For learning outcomes number 1, okay. The upon completion of this subject, you should be able to describe the basic concepts of first and second order. Okay, we will just scope at the second order. Okay, scope at the second order. That means you will learn how to solve the first and second order differential equations. Then you will learn Laplace transform and Fourier series. Okay, LO number 2. Okay, you will know how to solve problems that involve differential equations by using appropriate techniques. Because different differential equations, you will need different methods, okay, or different techniques. Okay, and the last learning outcome is you will know how to apply the concept of differential equations in solving engineering problems. Okay. Go to this one. The breakdown of the assessment. Okay, you will have one test, okay, 1 midterm that covers 20%. Okay, quizzes for differential equation, normally there are 2. Normally there are 2 quizzes. This semester, I'm not sure, I think 2. Then 1 group assignment and 1 final exam. Okay, so you can choose your own group members for the group assignment. Okay, course content. Okay, for chapter 1, okay, you will look at the introduction to the ODE. Okay, ordinary differential equation. Okay, and later we will look at the order, the linearity, and the homogeneity of the ODE. Okay, then we will look at how to solve the first order differential equations. Okay, there are different categories of the differential equation, but we will just focus on these 2, separable and linear equations. Okay, and this one, okay, these are under analytical. We will solve this under analytical methods. Okay, but for week 2, these numerical methods. That means we will solve a differential equation using numerical methods. A lot of calculations. You need to use a calculator. Okay, for chapter 2, okay, you will learn how to solve a homogeneous equation with constant coefficient and also the non-homogeneous equation. using these two different methods. Okay, two different methods. Okay, normally, chapter 2, okay, you will look, if you look, for the past year question, okay, if you look through the past year questions, you will see that past year question contains this chapter 2, starting from chapter 2. Chapter 1, I'm not sure, okay, you can refer back, okay, I can't remember. Okay, but chapter 2, you will see, the question from chapter 2 for the final exam. Okay, chapter 2, chapter 3, chapter 4, chapter 2 onwards. But chapter 1, I can't remember. Okay, we have to refer back to the past year question. Okay, for chapter 2, okay, this is still analytical. Okay, we are solving this analytical. That means all related to the derivation. Okay, derivation. Okay, chapter 3 is something new to you. Okay, something new because it involves Laplace transform. Okay, we will transform. Okay, we will transform the equation into Laplace. Okay, that's why we call it as Laplace transform. After we transform it into Laplace, then we solve it and we apply the inverse Laplace to get the solutions. Okay, so Laplace transform, yeah. It takes 2 weeks time for the Laplace transform, and this 2 weeks time for the inverse Laplace transform. Okay, so after you learn the inverse Laplace transform, then you will know how to solve the initial value problem. Okay, that means here we will start to solve for the differential equation by using Laplace transform. Okay, here the first 3 weeks you are learning about the basic of the Laplace and inverse Laplace transform. Okay, now after that we will use it to solve the differential equation. Okay, chapter 4 is about the Fourier series. Okay, Fourier series. So, okay, so under this chapter 4, we have Fourier series, half range Fourier series. Okay, and this involves the massive use of integration by parts. That's means we will use tabular method. Okay, tabular method for this chapter 4. Okay, so that means this is under analytical. Okay, and the last chapter, partial differential equations. Okay, the partial differential equations is different from the ODE, the ordinary differential equations. Okay, if you look at the difference later, okay, we'll touch a little bit on the PDE later. Okay, so for ODE and PDE, you will learn about the order, the linearity, the homogeneity, and the classification. Okay. Then this method of separation of variable is the analytical method to solve a PDE. Okay, analytical method to solve a PDE. Okay, so the application of PDE, we will look at these two. Okay, we will look at these two application. Okay, on how to solve the heat equation and wave equations using method of separation of variables. Okay, so this is analytical method, and we have numerical methods to solve the PDE. Okay, and if we look at only these two, parabolic and hyperbolic. Okay, so this two involves a lot of calculations. Okay. Okay. Any questions so far? Okay, so now we start our lecture. Okay, chapter 1, introduction. Introduction to ODE. ODE stands for ordinary differential equations. Okay, ODE. Okay, we look at how to identify the order of differential equations. Okay, now after that, linear, whether it is linear or non-linear differential equation, and the homogeneity. Homogeneity, that means whether the differential equation is homo or non-homogeneous. Okay, we'll look at these three first. Okay, so where we will see the differential equation. Okay, actually it comes from the mathematical modeling. Okay, so starting from the problem statement. Okay, let's say we have a problem. Then we will try to derive. Okay, we will try to derive the model by applying some assumptions or some hypotheses or some laws. Okay, then we get the mathematical problem. Okay, from problem statement, we can form a mathematical problem. And from this mathematical problem, that means this is the differential equation. Okay, we will solve the differential equation to get the mathematical solution. Okay, so this is what you are going to learn. From here, solve this to get the mathematical solution. Okay, and you will also need to know how to interpret your result. Okay, how to interpret your result. What is charge? What is current? Okay, after you solve the differential equation. Okay, so since this is a mathematical modeling, so once you get the interpretation problem solution, okay, we will try to compare whether our result from the derivation is it matched with the result from the experiment. Okay, if yes, that means this is a good mathematical model. Otherwise, you will modify the model, okay, to get a good fit model that can represent the real life problem. Okay, this is the process to do the mathematical modeling. But of course, we are not doing on this. Okay, we will just look at how to solve the mathematical problem to get the mathematical solution. Okay, this is one of the examples. Okay, example in electrical circuit. Okay, so this is the problem statement. Okay, by applying this law, we can get the mathematical problem. Okay, this is the mathematical problem, and this is the initial values. Okay, after you solve this, you will get the solution. Okay, so after you interpret, this means you know at what time, what is the charge, what is the current. Okay, so we will look at this part. Actually, we will look at this part. Okay, this is just an example. Okay, now we will start with the classification of differential equations. Okay, we have two types of differential equation. One is ODE, another one is PDE. Okay, ordinary versus partial. Okay, for ordinary differential equation, it involves only single independent variable. Okay, what is an independent variable? We will look at the variable from the this denominator. This is x. This is x. Okay, we have only x at the bottom. So this is single independent variable. Okay, this is also single independent variable. We have only x. No matter this is x squared or x cubed. Okay, as long as this is x, we have only x. Then that is single independent variable. Okay, if you look at this example, okay, here we have x and also t. Okay, this is more than one. When you have more than one or two or more, that means two and above independent variables, then this is called partial differential equations. Okay, so that's the difference between ordinary and PDE. We will look at here. Okay, x and t. This is also more than one, x and y. Okay, and when we denote the ODE and PDE, we use different notation. Okay, you see for ODE, we use D. Okay, we use D for ODE. But for PDE, we use delta. Okay, delta. See, this is delta. This is not D, but delta. Okay, ODE to PDE. Okay, we just look at the number of independent variable. Independent variable, that means the variable at the bottom. Dependent variable, that means the variable at the top. Dependent, independent. Okay. Yeah. Okay, independent and dependent. And independent variable is the variable located at the denominator at the bottom. Okay, the one at the bottom is independent variable. Okay, for example, time. t. That is change in the scientific experiment to test the effect on the dependent variable. Okay, dependent variable located at denominator. So G is the dependent variable, X is the independent variable. So normally we will change the X and look at the effects that change or impact to the G. Okay, that's why X is independent because we are free to change the independent values. And we look at what are the effects that it impose to the dependent variable, how it affects the G when we change X. So G is the dependent variable. Okay, depends. Okay, G depends on the X. So G is dependent variable. X are free to adjust. So X, this one at bottom, is the independent variable. So if you are given a differential equation, okay, if you are asked to identify independent variable, so independent variable from this example is X, okay, and dependent variable is G. Okay, and from this PDE, independent variable are X and Y. Okay, X and Y, and the dependent variable is F. Okay, dependent variable, the one at the top. Okay, so these are the independent and dependent variables. Okay, any questions? Okay. And next we look at the order. Okay, what is the order of a differential equation? Okay, the order of a differential equation is the highest derivative present in the differential equation. Okay, which is this one. This one, n. N is the order. Okay, so if you look at this one, this example, we have only one derivative. Okay, this is called derivative. dny over dx, and this is derivative. Okay, so in this differential equation, we have only one derivative, and the value of n is 2. So that's why this is second order. Second order because of this term. Okay, if you look at this, we have only one derivative, dy dx. Okay, we have only one dy dx, one derivative, which is dy dx, and the n value is 1, d1y dx power of 1. So that's why this is first order. First order due to this dy dx. This is not the order. This is power of 4, not order. Order, that means this one, n. Okay, so if you look at this answer number 1, okay, we have only one derivative. So what is the order for A? The first order because of b1y dx1. And B, first order, okay, dy dx because of dy dx. C, second order. Okay, for C, we have more than one derivative. Okay, this is the derivative. This is also derivative. We have two derivatives, but we will look at the highest one. The highest one. This is first order. This is second order. So the highest one is second order. So the answer for this one is second order. Okay, and for D, okay, D, second order. Okay, we have two derivatives, but the highest one is second order. And E, second order. Okay, because of this term, second order. This is first order. Okay. Okay, next one, we look at the linearity. Linearity does mean whether it is linear or non-linear. Okay. This is a general form of linear differential equation of order 2. Okay, second order, order 2. Okay, this is linear. There are two. Okay, there are two criteria for a differential equation to be categorized as linear differential equation. Okay, the first criteria is all this derivative and also the dependent variable must be appear only to the first degree. That means the power of 1. First degree is power of 1. That means power of 1. This is also power of 1. This is also y power of 1. All these derivatives and dependent variable must be power of 1. Okay. And the second criteria is, okay, the independent variable is x, right? Independent variable is x. So the coefficient function, for all this must be in function of x. And also the right-hand side function. The right-hand side function, this is free from the dependent variable, right? Okay, here you see the y. The one without y, we put it at the right-hand side. So this coefficient function and also the right-hand side function, which is nothing to do with the dependent variable, this one, all of them must be function in dependent variable. I mentioned dependent variable because we can change this x into any alphabet. It can be du dv. Okay. It can be d square u dv square. If this is v, that means all this must be in v. The coefficient function must be in independent variable. Okay. Constant, okay, constant also accepted. Okay, constant, because constant is also a polynomial with degree of 0, right? No matter, this one can be any function, can be polynomial, can be exponential function, can be any function as long as it is in x, in independent variable. Okay, in independent variable. So there are two criteria. I repeat, two criteria for a differential equation to be categorized as linear differential equation. The first one is all these derivatives and also the dependent variable must be degree of 1 or power of 1. Okay, this one, power of 1, y power of 1. And the second criteria is the coefficient function of the derivative and also the dependent variable, as long as and also as well as the right-hand side function must be in independent variable. Two criteria. Okay, so if a differential equation cannot be written, okay, or if any of these criteria is being violated, that means the differential equation is non-linear. Okay, non-linear. It must be the two criteria must be satisfied. Okay, to be a linear differential equation. Okay, now if you look at this hands-on number 2, is this linear?
No.
Okay, we check it one by one for the criteria. Criteria 1. Is it all the derivative and also the dependent variable appears to degree of 1? Yes or no? Why no? Why no? This one is order. This is order, not degree. The degree does mean you have a bracket power of a value, that is degree. So this is compared to the first degree, power of 1. Okay, this is degree, not power. Okay, d and y dx n. So this is degree of 1. Y is also degree of 1. Okay, so first criteria is satisfied. And the second criteria, okay, independent variable is x. Is this x?
Yes.
This one, constant, accepted. Constant is accepted. Is this x? So this is linear. This is a linear differential equation. Any questions? Linear, because this is power of 1, okay, or degree of 1. degree of power, that's means a big bracket outside. This one, something like this. This is degree of 2. Okay, this is degree of 2. But this is degree of 1. Normally, degree of 1, we didn't put the power of 1. Right? Okay, so this is linear. Okay. For B, is this linear? Okay, no, this is non-linear because of this. Okay, degree of 2. Okay, degree of 2. Okay, Y is in degree of 1, no issue here. But this one is in degree of 2. And other than that, do you see any factor that leads it to the non-linear category? Any more? Other than this issue, other than this factor? Exponential function. This is accepted. Okay, any function is accepted as long as this is function in x. The independent variable is x. The coefficient function is x. This one is a function in x. This is a constant, so accepted. So the only factor that leads it to the non-linear differential equation is this. Okay, that's means this term. Okay, only this term. This is the only cause. Okay. For the coefficient function, it can be any function, polynomial function, non-function, trigonometric function, any function as long as it is in independent variable. If this is x, this one must be x. Independent variable, it must be stay at the bottom. The one at the top, this is y is dependent. Oh, okay. If you have dx dy, okay, dx dy, that means y is independent. Y is independent, then all of this should be in y. That's means it will follow the independent variable. If you have dr ds, dr over ds, all this must be in s or constant. Okay. Okay, C. Is it linear? Is it linear? The answer is linear. Linear. Okay. This derivative appears to degree of 1. This one also degree of 1. Okay, this one you need to open the bracket xy, right? And xy you need to move to the left minus xy. And the y appears to degree of 1. And then the coefficient function of this one, okay, x is the independent. X is independent, so this one in x. This one is a constant. This one is in x. And the right-hand side function is x arcsine x. Okay, this one you need to open the bracket. The xy you need to bring to the left. And so that your right-hand side is x arcsine x. So x arcsine x is in x. Okay, so this is linear. Okay, open the bracket. Xy plus x arcsine x. And the xy will move to the left. Okay. No, arcsine x, x arcsine x, we leave it at the right hand side. Because it doesn't contain any y, right? It doesn't contain any y, just like this one. It stays on the right because it does not multiply to any of the y. You don't see any y here. Okay. The one with dependent variable, we let it stay on the left. The one without dependent variable stay on the right. So you have to know what is dependent variable, what is independent variable. Okay, B.
No.
Linear or non-linear? Non-linear. Non-linear. Why it is non-linear? Which terms cause the non-linear? Y squared. Because it allows only degree of 1, but this is 2. Okay, the rest, no issue. This is degree of 1, degree of 1. And then the coefficient function is constant. This one also -1 constant. And on the right hand side, this is in x. Okay, x is independent. This one in x. Okay, so no issue. Only this term cause the non-linear. Okay, last one. Non-linear because of this term. Okay, because of this square. The rest, no issue. Okay, no issue because y, degree of 1, and then x is the independent variable. So this is independent variable. This is also independent variable. This is constant. Okay, so now we use the equation from hands-on number 1, which check for the linearity. Is it linear?
Linear.
Linear. Okay, linear. B, non-linear because of the square, because of this. Okay, because of this term. Okay, because of this term. C,
Linear.
linear. D, non-linear because of y square. And also the sine y, right? Because your x is independent variable, but this is not in x. This is also not in x. This is also not in x. Okay, last one. Non-linear because of power of 3 and y because of this. This is not in x. This should be in x. Okay, the rest, no issue. Okay, so this is the linearity. Okay, for hands-on number 2, we look at the order. Okay, we revise order. What is the order for A? Second. Okay. B. Second. Okay. C. D. E. First. Okay, first. Okay, next one. We look at the homogeneity. Homogeneity, that means either homo or non-homo. Okay. So the differential equation we will display in this form where the derivatives and also the dependent variable, they stay on the left. And the one without the dependent variable, it stays on the right. Okay. So if the right hand side function is 0, that means it is homogeneous. If it is 0, that means homo. If non-zero, that means non-homo. Okay, so in simple words, if there is a term without multiplying to the dependent variable, that means non-homo. We look at the hands-on number 3 first. Okay, this one. Homo or non-homo? Homo. B? Non-homo. C? Non-homo. Non-homo. This one should be on the right. Because x is not multiplied to any of the derivatives or dependent variable. So this should be on the right, should be equals to -x. So this is non-homo. So you see the one for homo, okay, the one for homo, all of the terms, you will see the dependent variable. When you see a term without the dependent variable, it will be non-homo. So this is the simplest way to identify whether it is homo or non-homo. Okay, if all of the terms you see the dependent variable, this one it has y here, this one it has y here, this one it has y here. Okay, all of the terms with y with dependent variable, yes, homo. This one got dependent variable, no dependent variable, non-homo. Because the term that we didn't multiply to the dependent variable, we will put it at the right hand side. Okay. When you put it at the right hand side, it is non-zero. It will be non-homo. Okay. Now we go back to the hands-on number 2 equations. A, homo or non-homo? Non-homo. You don't see the y here, right? Number 2, B, homo. Okay, homo. There's a y here, there's a y here. Y is the dependent variable. Okay, C, non-homo. Non-homo, because after you open the bracket, the x outside x has no y, has no dependent variable. Okay, D,
non-homo.
non-homo, because there's no dependent variable here. Okay, E, homo. Okay, there's a dependent variable and dependent variable here. Okay. And now we look at hands-on number 1's differential equation. A, homo or non-homo?
Non-homo.
Non-homo, there's no y here. Okay. B, non-homo, no y here. C, non-homo, okay, no y here. D, D is homo. D is homo. Every single term you see the y. Okay. E, non-homo. Okay. So the differential equations actually is not only the linearity and homogeneity. Sometimes we need to know whether it is linear homogeneous or linear non-homogeneous. Just like this example, you see this one. This equation, when this is 0, it's known as linear homogeneous or linear non-homogeneous. Okay, so when you see linear and homo together, you have to check for the criteria of the linearity and also homogeneity. Okay, you need to be clear on the criteria on these two. Okay, this one, why this is linear homo? Linear homo because it is linear. Okay, because it is linear. So what is linear? We call what is linear? Power of 1, power of 1, power of 1. And the coefficient function must be all in independent variable. Okay, as well as the right hand side function. Linear. So this is linear and also homo. Okay, linear and homo. If this is 0, I'm sorry, if this is 0, that means it is linear and homo. So we call it as linear homogeneous. Okay, if it is linear and non-homo, then it is linear non-homogeneous. So when they mix together, that might be confusing you. Okay, so you must be clear with what is linearity, what is homogeneity. Okay. Okay, just like this one, this is linear. This is linear. Linear non-homo. Okay, this is linear non-homo. So linear non-homogeneous. Okay, this is non-linear but homo. Okay, so when you look at the question, you have to look carefully whether it is asked linear homogeneous or homogeneous on B. Linear homogeneous and homogeneous are different. Linear homogeneous, that means it must be linear and homogeneous. Homogeneous means we don't care whether it's linear or non-linear, as long as it is homogeneous. Okay.
Pergi kosong dulu. Bukan air. Ya. Itu nah. Kalau ambil komputer.
So for today, I will stop here, okay? Because we will have new students, actually students from intake semester 2. There's many new students who join newly in this semester. So maybe students will take one slot in section 1, one slot in section 2. So I have to make sure both sections run in the same pace. So that's why I will leave it to next week. Okay, so for section 2, I will see you next Tuesday. Tuesday, right? Tuesday and Tuesday.
Tuesday.